In this video, we will be finding the domain of root of mod of box x minus 2 divided by mod of box x minus 3. First of all, this value inside the root. That means f of x equal to root x. Then x should be positive or x can be 0. X shouldn't be negative. That's the condition. So it is of the form root x form. So in root x form, this will be, that is mod of box x minus 2 divided by mod of box x minus 3 should be greater than or equal to 0. Now I am substituting mod of box x as y. Therefore, y minus 2 divided by y minus 3 should be greater than 0. Now we have the roots, so we will be drawing it in a number line. So no, root of numerator is 2 and denominator it will be 3, and we can't provide the value 3 as y. If you put y equal to 3, this value, the function will become not defined. Therefore, you can't give this value as 3. But if you put y equal to 2, 2 minus 2 greater than or equal to 0, that is 0 greater than or equal to 0 still satisfies. So you can directly put the y value as 2. Now this will be plus minus plus. Now from here, y value should be less than or equal to, y value will be equal to less than or equal to 2, and from here the y value should be greater than 3. Then because we have the greater than sign over this expression, that's why we took the positive sign. Now actually y value is box of mod of box of x less than or equal to 2 and mod of box of x greater than 3 is our y value. From here, suppose it is given that mod of x is less than a means minus a less than or equal to, if it is less than or equal to, then minus a less than or equal to x less than or equal to a. Here mod of box x is less than 2, which means minus 2 less than or equal to box x less than or equal to 2. Now we can draw a number line and we can see what are the possible values of x which satisfies this relation. So box x value can have a least value of minus 2 and the maximum value of 2. Least value of minus 2 and the maximum value of 2. Therefore, if you take an integer before 2, that is before 2 but less than 3, if this is our x, that is x is an element in this region, x is element in this region, then box x will be 2 only. It won't become 3, which means we can give value till 3 we can give, but we can't give 3. Box of 3 will be equal to 2. It's already given that box of x should be less than 2. That's a condition, right? Now here, if you take a value beyond this minus 0.2, if you take a value beyond this minus 0.2, suppose it is minus 2.21, minus 2.1, then this box value will become minus 3 because it is always goes to the next integer. In that sense, we can give till minus 2 is possible, and here it will be open and here it will be closed. So the solution of this part will be equal to, this particular region will be equal to minus 2 closed minus 2 comma 3. Here we need to solve this also, and then we need to take the union of our final answer. So here there will be two cases will be there. That is mod of box x should be greater than 3. Mod of box x should be greater than 3. For that I am using the graphical method. Mod of box x should be greater than 3. Now in the graph, the thing is modulus means the absolute value, which means distance from origin. In that perspective, the box x value should be greater than 3. That means in this region, or the mod of box x should be greater than, that is the box x should be, the mod of box x should be means the absolute value is greater than. So from minus 3, if you take a value, box x is from this region, that is suppose you put x equal to minus 4, then box x will be minus 4, then it will be greater than 3, which means the value, the thing is the box x value, suppose mod of x is greater than 5, which means the absolute value of x is greater than 5. So if you take a number after 5, from 5 to infinity, it will satisfy. If you take a value in this side also, minus 5 to minus infinity, if you take a random number minus 6, so box of minus 6 is greater than 5, it valid, because the thing is we only need this region, the region of region, that's a distance only we need. So in that logic we will be going with the graphical method. So this is the region, right? Here box x should be greater than 3. Here box x should be greater than 3. and here box x should be less than minus 3. Then only when you take the magnitude you will get it. So here this value will be from box x is less than minus 3 means if you take a number from less than minus 3 means the minimum value. See, box x is less than minus 3. Box x is less than minus 3 means box x is always an integer value, right? Integral value. Which means box x can have a value of minus 4 or less. That's the logic. Which means here it will be from open 3 to minus infinity. Because if you take a value beyond 3, if you take it more, if you take a value slightly beyond minus 3, then the box x will give a minus 3. We only need box x value starting from minus 4. That means it will be minus infinity to open minus 3, that is in this region. Now here box x is greater than 3, right? Box x is greater than 3 means what is the logic? Box x is greater than 3. Box x is greater than 3. Since it is an integer value, it can only take next integer value. This should be greater than or equal to 4. Which means from here you should give values from 4 to infinity. Then only it will satisfy. That means this will be from 4 to infinity. So our final answer will be minus infinity comma minus 3 union closed minus 2 to 3 closed minus 2 to 3 union 1 4 to infinity. That's how we will be solving this expression.